Yeah, so I think my path into soil science kind of started with I had a huge forest behind my house, luckily, and so me and my dog would walk back there constantly, like every week or every other week or so. And one time, about 2 or 3 years into our kind of adventures into this forest, we came across this big part of the forest, and it was completely cut down, like in the middle of the woods. Just the forest was cleared out completely. All the trees and the vegetation was stacked up in a pile, and the forest was just clear cut. And that was pretty disappointing, to say the least. That was like a very fun place for me and my dog to go. So that was my first interest in like environmental science and conservation and sustainability. And so then I got to college and I majored in environmental science. And then I started learning all about these different ways that even when you're eating like healthy vegetables and healthy produce, you can still be contaminated and harming your body if they have contamination in them. So I got kind of really interested in this, and I got into this undergraduate lab where I did some research with arsenic uptake in rice plants. And that was kind of my first step into contamination, and kind of learning about how metals and plants interact, and how the soil interacts with the plants, and how these are all like interconnected, and how we can work to best mitigate contamination, kind of keep, if people are trying to eat healthy, help them to be as healthy as they can be, and not have them risk hurting their bodies. So that was kind of my first intro into it, and then kind of just, I knew I wanted to go to graduate school. I knew I wanted to get a graduate degree in this kind of field, in this field of contamination. And so I started looking at different schools, and I also had a big interest in urban agriculture, coming from a city like Pittsburgh. I found this project, and I found that Andrew was working really heavily in Chicago, and that was really interesting to me.
I had a similar path as George, I think, having interest in more food and health. I read a Michael Pollan book, actually, and that kind of made me shift gears completely from more chemistry track. So in undergrad, I didn't grow up around ag. I had no idea. I was a suburban kid who played in the woods as well. Studied philosophy, chemistry, and undergraduate as my majors, and then just kind of switched because I felt like there were lots of other things going on in the world, and a lot of them dealt with food, and that seemed to keep boiling back down to soil, sustainable usage of soils. So I went to graduate school. I went to UC Davis for my PhD, got involved with work in East Africa with small farmers, participatory work, and that really got me thinking about science done for the people it's supposed to benefit probably should start with those people when informing questions for research. One of my mandates was to work on urban agriculture in Chicago. It's thought to be a hotspot of urban agriculture. It's the third biggest metro region in our country. And here it's being done quite a bit because of lot vacancy, urban ag, I mean. So, being trained in soil science, soil chemistry, my first thought was, I understand lead is an issue in Chicago, and this is as a newcomer from the East Coast with no knowledge. And so we decided to work on lead contamination to understand, is lead in fact a threat? Could it undermine good intentions of growing produce locally, be it for auto consumption, be it for these food swamps or food security? So let's understand the biophysical, almost an existentialist threat to urban agriculture, which is heavy metal contamination, things like lead. So that's what brings us here today. Is we wrote a project, we meaning a team of faculty at U of I, teaming up with Cook County U of I Extension, notably Zach Grant. We wrote a grant that was informed by workshops with urban residents trying to address questions that they wanted us to research. So we literally asked them things like, what crops do you want us to look at? That's why there's tomatoes behind us. They said, look at tomatoes. Are my tomatoes safe? They also told us things like, do you want us to focus on new ways to test for lead that are more affordable? Do you want us to focus on X or Y? Those kinds of responses informed the project that we're working on now in the second year. The whole idea was to understand, just to get a handle to gauge, is there a lead problem? A lot of popular press on this in drinking water. Soils are different. So we just began scanning soils, walking out in neighborhoods and just testing soils. We had workshops like the Good Food Festival in Chicago, the Chicago Community Gardeners Association Conference in 2018. And that's when they were bringing us soils saying, hey, how much lead is in this sample? They'd ask us questions like, can I use sunflowers to clean up my soil if there's lead? So those are the kinds of questions that we got that led us to think maybe we should tackle the lead question more specifically. We knew from scientific studies in other cities, like in Twin Cities, there's Professor Nick Jelinski, new faculty member there as well, doing similar work on identifying where in the city the lead is, so sampling soils on a grid. And then also, what are some of the ecosystem services of urban agriculture is what he's worked on. So there's a lot of scientific literature out there on things like, well, we know urban regions have lead. It tends to be very, very patchy. You'll walk 5 feet over, it totally changes. So we had that scientific background. We knew questions, or we had answers to questions on the chemistry of lead. Is it actually available for the plant to take up? But then there's questions that are more, I don't want to say practical, it's because that implies that a lot of science work isn't practical, that are more immediate, let's say. Like, I need to know tomorrow, what do I plant, for example? I need to know if here versus there in my garden has a high amount of lead. So we wanted to really, given that theory, begin with the questions. So we drew up a list of questions that we thought might be of interest. We also had blank sections with write in your questions. And then we let people literally rank. We tallied up their votes, and we went with the top 5 questions that they asked us. Then we wrote the grant, which is a University of Illinois interdisciplinary collaborations in extension. And it's meant to bring together researchers like myself, faculty whose main appointment is lab, with extension agents like Zach Grant at U of I Extension Cook County. The idea being that the researchers can develop the data and the interpretation of that data to answer questions, but working with extension agents to co-develop those questions so that they are more tractable, they make sense to people, and then to disseminate them. So from the get-go, it was also meant to be this hybridized project.
Yeah, I think one of the best things that's happened with this project is when we do run these workshops and presentations all throughout the city of Chicago, we spend most of the time just kind of answering questions and conversating with the stakeholders and the people that come to these meetings. You know, I've learned a lot about science communication, but also just how people think about urban agriculture, how people think about contamination in their soils from these kind of conferences and these meetings. And so seeing how people, you know, what they understand and like how to better communicate these like kind of complex ideas and these complex topics to a wider range of audience and a more diverse background of audiences too. And it has factored into how our project has changed, you know. Now we're like more interested in phytoremediation based on all the questions we've gotten. Like we've done more work on that. We've looked into that a little bit more. Same thing with like the mapping project. I think a lot of that was, a lot of the details, the specifics on that project has been born out of questions we got at these community outreach events. So specifically kind of areas to sample in. Like, you know, we get a lot of engagement about people wanting to sample, you know, in certain neighborhoods, and so we're able to kind of find these hot spots of where there's the most interest and really hit those areas hard with sampling efforts. Yeah, so Citizen Science is this really cool initiative where we just have regular people that live in Chicago that maybe don't have a scientific background, maybe they don't have a degree in science in a scientific field.
The way that I would take that term is simply non-scientists that help in collecting data. Either directly themselves they can get data. So think of bird watching, species watching. That's a very common approach of citizen science. And there's also that they can support data collection. And there's even then 2 senses. One might be passive, where you're letting people access your sites and you let them get the data. Then there's also more active facilitation. So for example, providing research questions to the scientists to pursue. So there's within the indirect still, I think, 2 different levels of engagement. And they all have their place. There's some things that are best answered or addressed by one of those different flavors or layers of citizen science. But in short, exactly, it's looking at how can non-scientists help collect data.
And so what happens is we kind of communicate our scientific knowledge to them, and then they help us with the project. So one thing that they do that's really helpful for us is mail-in. So people from around the city will mail in their soils to us, and then we scan their soil for lead contamination. That helps us build this lead map, the map of lead contamination, and it also helps us get an idea of where there's the most engagement in the city, where people are most interested in this project. And then where there aren't, we know we can go to those places and try to really get more involved in the areas where we're not getting a lot of mail-ins, where we're not seeing as many mail-ins. So I think so citizen science really is just regular citizens that want to be involved in the scientific process, that want to help publish papers, and want to help get data out there that helps, people from across the city and across the world.
And the advantage is that there may not be a lot of technical expertise that you need to still contribute to quality data. And when there's a obstacle of the small data problem, to go against the big data term, just fanning out and having more boots on the ground, more eyes in the sky can help you get that kind of data. So we saw that initially as a way to, well, in all senses. So for example, we're doing these on-farm trials. Wonderful hosts are letting us come to their farm, to their backyard, and to implement experimental trials. These are experiments that are as rigorous as any that we would be doing in any other domain of ag science. And that's letting us collect that data. Because of the workshops we had, we're using different experimental treatments, we're testing different things that were directly voted on by stakeholders. And then, as George is getting at with this open access map of where in Chicago is soil lead a problem, that is in part fueled by the contributions, people mailing in their own soils. So that's another way, and that's the more classical way of citizen science.
And this gets really important because I can only sample on public property, right? When we built this map, we have around 2,000 soil samples that I collected, and they can only be on the parkways. That's technically public domain, and you can take the soil from that area. But that's not where people are growing food, and that's only half the battle, really, when we're looking at trying to study where the lead contamination is in the city. So by having people mail in soil from their backyards, from different plots that we really can't access, it's very helpful to help develop that map and get a higher resolution of the lead contamination around the city. So I think we currently have around 500 or so mail-in soil samples, and so we're looking to get as many as possible. And the more we get, the finer the resolution is, and then the more accurate the map is for the probability that you have a lead contamination above a certain level, and above that, like the qualifying level for how much lead is too much in the soil.
So the proposal that was funded, we have 4 goals in that proposal, and we're on track to deliver, I believe, on all of them. So number 1 is let's make an open access lead map for citizens of Chicago. So across soils in Chicagoland, where's the lead? Where are the hot spots? Too much lead? What exactly are those concentrations? That information I think people have a right to know, especially from public lands like parkways. So there's just a massive lack of knowledge, a knowledge gap that we're hoping to fill. That will be published at the end of this study in the next year as an online web page where people can look at Chicago, they can zoom in. We protect the privacy of where the samples were taken, so there's no point sources indicating at this exact GPS spot there's this much lead. Instead, they're density maps, so think of like color-coded green to red. So that's the first product, because we think people they have the right to know. Second is we're going to co-develop these rapid, inexpensive tools for testing lead. Right now, doing a lead test is expensive. It takes a couple weeks or more, but really it's the expense that is the problem. We know that lead can vary in lots of places in a short distance. So if you want to test your different garden plots, it might rack up. We're talking maybe $70 to $80 a sample. So if we can develop the science of a rapid infrared or X-ray light-based technique, which is what we're trying to do, it might offer a very low cost substitute. And we're talking like maybe $1 a sample, conceivably, just for labor. So we're going to sacrifice some accuracy, but for much lower costs. That's more accessible. Now these two things work together. If you have a probability map of if you're in this ward or this neighborhood, you have an 80% chance of having soil with a value of lead that is above what the federal EPA recommends as safe for dust inhalation. So then that might be the basis of them deciding to invest in soil testing. So those are the first 2 products, the open access map, the rapid high throughput technique. The other 2 products are derived from the on-farm work, and that's what you're seeing behind us. So this is where we're trying to understand what are the safest crop choices, what are the best bets. If you know you have a high amount of lead in your soil and or you just want to mitigate the risk because you don't know, what are the safe crops? Again, focusing on crops that people asked us to study. And then the 4th deliverable is pairing with that, Not just can you mitigate risk by choosing certain crop types, can you actively decrease that risk for the uptake by the plant from the soil of the lead. So this is what we're also doing with these on-farm trials, is that we have a experimental evaluation of different amendments, things that have organic matter, things that have phosphates, which are known from the science world to bind and to lock up the lead. It locks it up, the plant can't get into it, so now the fruits, literally, of those plants are more safe to consume. We don't really know what works in general, and not in these soil types of Chicago. So that will be the fourth outcome of what's the best bet in terms of a mitigation approach for these amendments for urban agriculture.
Driving around the city and taking soil samples, I got to see like the entire city. You know, I went all the way up to like Howard Street at the very northern part of the city, all the way down to talking about 120th Street, 130th Street or so. So I really got to get a good idea of what the city is like and kind of really find out this like the urban studies of the city and how it changes so drastically in such a short distance, and how diverse Chicago is as well. People will come up to me all the time and just ask me questions like, "What are you doing? What are you researching?" And that was really powerful to kind of get at everyday people who you just see walking on the street. It's like a random sample, really, of citizens of Chicago that are just out and about, and kind of getting to see what they think about this project, what they think about soils, how they think about research, and how we can best disseminate this information to these people.
I think there's three things that stood out to me, and they get at these questions from intersectionality of how people might be using their soils across the city. So the first one might be is that there's a culture of urban agriculture in the same way that any kind of agriculture has the culture, right? There's a way of thinking perhaps, or there's perhaps ways of thinking. There's a plurality of them. And part of what I think is fascinating about agriculture is that it does integrate the human with the abiotic or the landscape. So people grow certain crops because of the biophysical constraints. It's why there's pasta and tomato sauce in Italy, because that's what grew there historically. And if you think about urban agriculture, you might decouple yourself from the landscape because of the cultural diversity of many cities, especially a place like Chicago. We are fortunate to have a rich immigrant population of different cultures in the city. And so the kinds of crops being grown, even how they're being grown, are quite different. We've seen farms by Polish immigrants that look like you're in Central Europe. And we've glimpsed farms of, I believe, Chinese immigrants that are like anything that we've seen, or that are unlike anything that we've seen. There's different crop types. And there we have a shortcoming that we don't even know how to communicate with them about those kinds of crops. So there's quite a bit of diversity, I think, because of the tapestry of people. And it might, in contrast to, say, rural ag, be a little bit more separated or decoupled. That's neither bad nor good from the biophysical constraints. So that's one observation, is that I think you can't avoid the human aspect of urban ag, especially in a city as diverse as Chicago. So that's one thing. Second thing is that some of those people may not have the privilege or the access to information or other resources, perhaps in part because of those backgrounds. So for example, some folks may not be aware that lead is a risk, and some of those same farms owned by a Polish gentleman who was older in age, he was very much unconcerned about his soils being over 50 times what's normal naturally. And so that's a good example of how some of these same communities that have incredible biodiversity in their urban agriculture, they're using it in different ways. It's not just, say, decorative or to supplement a diet. It might actually be a big source of food and of nutrition. They may also have different kinds of risks because of those backgrounds. So this is not in our domain. We need to work with social scientists, with extension partners, and that's what we're doing, what we're planning on for the future. Another one that we've noticed is there's a need for scientists to do better. This also might present the situation of the land grant institution like the U of I in the 21st century. Land grants were developed for the U.S. as a way to serve the people, and specifically it was to educate and to do research that would help improve the lives of stakeholders. And this is 1880s, so most Americans were rural, most depended on agriculture for their livelihoods. And so the land-grant mission was born out of serving that population. In a place like Illinois, a whole lot of people live not in rural zones, they live in their urban environment, like in Chicago. So we might want to rethink how we can pivot the focus of the land grant to also address the urban population of our state. And now with that, there comes different kinds of challenges. Some are pretty fun. And one of these is not myth busting, but trying to understand how people perceive, how they understand, how they work with a resource like soil. Are they aware about lead? Are they perhaps thinking that certain approaches to deal with lead risk, for example, are effective, and why? For example, we've come across this notion of microbial mysticism, is what I'll call it, where microbes are magically able to heal soils. And I think philosophically there's some really important and deep reasons why that would be. Not in our domain to understand that, we don't have the skills. But we have worked with some anthropologists to understand, on a surface value, where this might be coming from. So to me, that's also an indication that we need, as a land grant, to engage with this population and to do a better job of education. And we are doing a great job, thanks to U of I Extension folks like Zach Grant. So things, for example, like, what are evidence-based practices? Why are people thinking that, say, sunflowers might remediate lead in soils when there's not too much evidence for that? I think we should study it because people think it is important. But there's also, again, the public land grant mission is to develop the knowledge so that things actually work, so that livelihoods are improved. So that, I think, is the third takeaway, is that because it's a new kind of stakeholder, we're also encountering different ways of thinking, different kinds of backgrounds of education, of science. That means we have to reconsider, perhaps, how we deliver that information to them.
Yeah, I think there's a few that I would really like to work with personally. First is people in the health field, health sciences. We were talking off camera about how one really interesting study that we could do is how people that grow produce in their yards and then consume that produce, what kind of lead contamination they have in their bodies, so in their blood and in other ways as well. So that would be a big aspect, is kind of working with, see how it actually impacts the human body, right? Because that's what we really care about ultimately, is how it impacts the person. Also, I think working with anthropologists and other social scientists to really get at how to answer these really difficult questions, like questions about scientific access to minority populations in Chicago. I mean, these are really difficult questions as people spend years just to try to get a little inkling on the idea of how we can best access these communities. Because it's a difficult question. It's not, if there was one simple answer, we would have done it by now, unfortunately. So I think that's another big group that I would like to really work with in the future. Additionally, I think people that are more focused on like urban studies in general, to kind of learn more about how urban agriculture pops up in the city, like where it comes from, and how we can like increase the access people have to urban agriculture, while also trying to like optimize where the best places for urban farms are. So this is dependent on like how neighborhoods develop, how houses get torn down, how vacant lots crop up, and then how we can best utilize those lots to help people that are food insecure and people that live in these food swamps and food deserts where they don't have access to like, you know, important nutrients, phytonutrients, flavonoids, everything like that, and just fruits and vegetables as well. So for me, those are probably the three main fields I'd like to work with.
We're soil dorks. We can do some things very well, but we definitely need to integrate, and not just parallel play, but, for example, what I would have given for us to have had a social scientist in those workshops that were the basis for identifying these questions. Now, to be fair, this was only a 2-year study. It's meant to initiate what we hope to grow into a greater, both in scale, but also in the kinds of questions we can address. So, for example, understanding the contextuality that is underlain by the cultural diversity of Chicago. Also, what urban ag can and cannot do might differ just by those communities. You think about the global north and the global south, how urban ag looks, how it's practiced, why its practice looks very differently. I also think there's a lot of, partnering with these other scientists in, say, social science can help us develop a way of doing urban ag that is not just tailorable, but also is more effective. So, some examples. We get lots of questions on this microbial mysticism. There's a reason for that, and to dismiss people's questions that may not be scientifically sound as just misinformation is irresponsible. There's a reason why. We should figure out why they're doing that, because then there might be a way to answer what they really are trying to get at. So, for example, I think with the microbial questions, people are concerned about the health of their soils. And that term itself is still a little bit vague, but there's, I think, a greater stewardship that you might be able to trace back in these microbially charged questions. That's just one example. I think for us to scale up to be effective, we also have to address that there's different kinds of urban ag. It can be from commercial. Chicago is notable in the amount of commercial urban farms. Then there's also backyard production. So we need to be careful to not fall into traps that urban ag is the silver bullet to say food deserts, or that food deserts is actually, as George has used the term, a food swamp might be more accurate. There's a lot of scholars who suggest that term itself might be a suburban white fantasy of how to rescue some communities from deeper problems. It's not simply grow some tomatoes and you've solved food insecurity. There's much deeper, generationally entrenched reasons and political reasons and racial reasons why certain parts of Chicago may not have access to certain kinds of foods. That is a huge endeavor, and so we definitely need to partner with historians, community leaders, not just social scientists and anthropologists.
I think for me personally, what I really would hope people take away from this is that it's easy to participate in scientific research. And it's not that, it's quick and it's not that expensive either. You can do it for free, basically. Just take soil sample and then drop it off at one of these drop-off locations that we're advertising across the city. But I also think a big takeaway is just how easy it is to get into urban agriculture in your area, especially in Chicago, where there's just so many open spaces that you can grow plants on. And we want to make sure that that's safe. And so the best way to do that is to participate in these programs that help us analyze the soil, help us analyze the contents of the soil for contamination. And so I think that's kind of the biggest takeaway for me, is that how we can help build up and how we can help further urban agriculture in the city of Chicago to make it as safe and as prolific as possible for developing, for helping with all these different aspects that urban agriculture can help with, from some help with food security to just some mental health, to help with mental health, with how gardening is good for you, and gardening, getting back to the soil and getting back to your roots as a human being. I think that can be really powerful, and that's kind of my big takeaway from this program.
It's kind of the whole point of the land grant, is to work for the people. We are public servants, and people should remember that the professors, the researchers at your state land grant, they work for you. As part of the specific projects for that engagement, we offer the data at no cost. By working with scientists, you do get data for oftentimes very low cost, and it might be kind of interesting. We are pretty thrilled when people ask us to come onto their backyard, like what we have behind us, to do an experiment. This is data that is going to be useful to inform best bets and evidence-based practices. So you have a part of that.